Okay, this video is going to talk about multiplying radicals, and I've done these first three problems for you so you can sort of see and pick up a pattern as to how we're going to do this. Because really once you understand what parts you multiply, the rest is stuff that we've seen before. So let's take a look at this first one. It's 2 root 3 times 3 root 7 equals 6 root 21. And if you're really quick, maybe you notice that, okay, well, 6 probably comes from 2 times 3. And the 21 will come from 7 times 3. And if you notice that, then you're right. You sort of stumbled upon this rule. You're going to multiply the coefficients in red and multiply the radicands, the things in the radical, things in yellow, and that's it. Okay? So again, you multiply the coefficients and multiply the radicands. Simplify the radical if you can, but in this case, there are no perfect squares that go into 21, so we're fine. In this case, your coefficients are 2 and 3. 2 times 3 gives you 6. There's no other radical to multiply with, so this just leaves it as 6 root 3. In this case, the only coefficient we can see is like a 2, but we can pretend there's a little 1 in front there. 2 times 1 gives you 2, and 3 times 7 gives you 21. Alright, let's try to apply that in a more difficult scenario. So like this thing, root 3 times 5 plus 2 root 2. Well, this kind of looks like a distributive property problem to me, and it is. That's all you're going to do. You're going to distribute that root 3 to everything there. Root 3 times 5, well, that is just 5 times root 3. Root 3 times 2 root 2, well, 2 is the only coefficient in that one, but we have a 3 and a 2 there. So it'll still be 2, but then it'll become the square root of 6, because of 3 times 2 gives you 6. And since these do not have the same radical, you cannot combine them. There's your answer. Easy. Last piece, and this is like really will draw on why I teach this with polynomials. Here we have x plus root 5 times x plus 3 root 5. And even though we have the radicals, it's still the same idea. When we're multiplying two binomials, so two terms, we need to remember to multiply everything in the first by everything in the second. And the way that I've taught you to do that is by using the box method. So you can still use the box method here. It'll still be effective for you. Okay, so we'll say, alright, x and root 5. We'll say x and 3 root 5. So x times x is x squared. X times 3 root 5, a little bit weird, but again, there's no radical on this x. Right, no radical on that x, so we can say 3 times x, the coefficients, that's 3x, root 5. Here, again, same idea, root 5 times x, that's just like 1x, root 5. And here, we have root 5 times 3 root 5. The coefficient's like a 1, so that becomes 3 root 25, and we'll simplify that in a second. If we add all these up, we have x squared plus 3x root 5 plus x root 5 plus 3 root 25. And from there we can do some simplification. These are like terms. 3x root 5 and x root 5 because they have the same radical. So 3x plus x is like 4x. And this thing, because the square root of 25 is just 5, that's like 3 times 5, and that is just 15. So again, we can use the same method we do with polynomials to make sure we multiply everything correctly in this situation as well.